Determining the continuity of a multivariable function is an extension of continuity in single variable functions. For instance, in our first function, we have x squared sine y equals our function. In this case, since x squared is defined at all points, and sine y is defined at all points, the total is also defined at all points. Our next example is cosine y over x squared. In this case, we are defined at all points except where x equals 0, because division by 0 gives us a 0 denominator, which means we're dividing by 0, which is not allowed. So this is x equals 0 is where we have a discontinuity. If we look at our next example, tangent x over x squared plus y squared plus 1, we notice that the denominator can never be 0, because x squared is always positive and y squared is always positive, or at least not negative. And these two plus 1, the minimum the denominator can be is 1. On contrast, though, tangent x is undefined at pi over 2, 90 degrees. Also at 3 pi over 2, 5 pi over 2, etc. Because tangent is undefined at that point. Likewise, our final function, e to the x y squared over 5 minus e to the z, a 3-variable multivariable function. The numerator, x squared times y to the power 2, is defined at all points. The denominator, however, gives us trouble because 5 minus e to the z is not defined when e to the z equals 5. Or in other words, z equals natural log of 5. This is the discontinuity for this point. In summation, determining continuity for multivariable functions is a logical extension of finding continuity for single variable functions. We determine where the function does and does not have legitimate values, and where those values have asymptotic discontinuities, such as tangent. Also look out for natural logarithms and the 0 denominators and other things that give us asymptotes.